Okie doke, I'm losing track, but I think this is the fourth video on economic growth, and it's the second one on the Solow and Ramsey models. And we didn't get far with the first one, did we? We just got to the Cobb-Douglas function, the constant saving rate, and then we looked at the property of the Cobb-Douglas function with the constant elasticity substitution. And what that elasticity was, which you hopefully all worked out now. Okay, what about the actual model? Well, this is basically, we're going to talk about this when we meet, because I want you to work this out for yourselves. Take the picture literally and answer the following. Okay, so hopefully you can all make sense of that picture. It's basically like this one, isn't it? But slightly different to this one. I think I'd have drawn it differently these days, but the capital stock, we don't see it in a separate box, we see it in the factory. Okay, the capital stock is inside the factory in that picture. So you should work out what is L, what is K, what is Y, what is big C, what's little s. And you should also find AL based on, of course, the assumption, it's not here, but the assumption of Cobb-Douglas. Okay, so we're assuming throughout here that production function is like this, yeah? The standard Cobb-Douglas form for the Solow model. And I'm telling you that A is 1/3, and then a bit later I tell you that delta, the depreciation rate, is 0.1, and then I say, okay, what is the long run steady state in this economy given that depreciation rate? So have a think about that, chat to your friends, so to speak. I hope you can all work that out pretty straightforwardly. We'll talk about it when we meet. Okay, so next thing, what happens in this model if we're taking this as a good description of real economies? What happens if the saving rate S differs across countries? Well, I'm just going to take you through the math of this. It's nothing you really need to know. It's not central for the course, but it's just to show you the kind of method that I'm going to be using here. You need to be able to do. Okay, I guess. Let me see. I'll say that at the end once I've done it, because I haven't prepared this actually. Okay, so we want to know the effect of different saving rates across countries. And straight away, I'm going to say, I'm going to say, let's define something called a steady state. So a steady state of the economy is a state when none of the variables are changing. Okay. So let's try and find that steady state. In a steady state, capital must be constant, okay? And we know that kt plus 1 is 1 minus delta kt plus s times y, okay? And y is AL to the 1 minus alpha k to the alpha, okay? And that should be t's and t and t. But then if it's a steady state, we know that kt plus 1 should be equal to kt, so we can write that plus 1 if we're in a steady state. Okay? So, and L is just constant. Yeah, L is given. So now we can work out K, can't we? We've got KT, 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 everything else is known. So let's see if we can do that. Let's take this over to the other side. Then we get delta KT is S ALL. We can drop the T. Actually, we're in a steady state. K to the alpha. Okay. So we want to solve this for K. So let's divide through by delta, and then we have S over delta. Now let's divide through by K to the power alpha. And we have that. And that is the same as K to the 1 minus alpha. Okay? So we've got K to the 1 minus alpha is S over delta ALL to the 1 minus alpha. Now we raise everything to the power of 1 over 1 minus alpha, and we get K is ALL to the 1 minus alpha to the 1 over 1 minus alpha, which is just ALL, and the S over delta to the 1 over 1 minus alpha. So what does this tell us? It tells us that if we raise S, we will raise K in the steady state. Okay, so if we save more, we'll end up with more. In the long run, we'll end up with more hammers or widgets in our box here, and more inputs. Okay, but how much will that affect production? Well, if we put K back into the production function, this one, whoops, that's off the page. If we put our value for K back into here, what do we get? We get Y is ALL, am I on the page here? Not quite. ALL to the 1 minus alpha, K to the alpha. So that's S over delta to the 1 over 1 minus alpha, ALL. That's K to the alpha. Okay? So, try and stay on page. That's ALL to the 1 minus alpha, ALL to the alpha. So Y is just ALL times S over delta to the alpha over 1 minus alpha. So, what does that tell us? It tells us that if we multiply S by 2, for instance, if we double the saving rate, we multiply Y by what? 2 to the alpha over 1 minus alpha. And alpha, we know, is around about 1/3. Because, as we'll talk about later, alpha, given the Cobb-Douglas function, alpha just tells us the factor share of capital, and 1 minus alpha is the factor share of labor. And we know empirically that the factor share of capital is approximately 1/3 and is constant more or less over time. This is one of the reasons why we like using the Cobb-Douglas function, because it has this property which fits the data. So if we set alpha equal to 1/3 and put that in here, that tells us that it's when we double the saving rate in the long run, how much more production do we get? 2 to the 1/3 over 2/3. 1/3 over 2/3 is 1 over 2, which is about 1.4. Okay, so what's that telling us? If we say that S is 20%, 0.2, and C, so then we're consuming 0.8y. If we double S, make it 40%, we will multiply y by 1.4 in the long run. In the short run, not much happens. And we'll multiply consumption by 0.6 over 0.8 times 1.4. We'll hardly get any more consumption. We'll have to sacrifice a lot in the short run because we'll save a lot more and have no more consumption. Then we build up the capital. In the distant future, or in about 20 years, we'll have very slightly more consumption. Okay, so what's that telling us? It's telling us that differences in saving rates hardly have any effect on GDP, long run GDP, in this model, which is telling us that the model is completely failing to explain differences in GDP between countries like Sweden and certain other bunch of other countries dotted around the world. Okay, it's completely failing to explain the differences in GDP between countries. Okay, and by the way, if there's a global capital market, it fails even more drastically, because according to the model, the returns to capital should be higher in countries where people aren't saving much. Then people, I could take you through the math for that too, but I'm not going to. Okay. If people aren't saving much, there's a shortage of capital. The technology is the same everywhere in the model. So people in the countries without much saving, they're like, oh, give us capital. The firms are like, oh, we need capital. Give us capital. We've got the technology. For countries which are saving a lot will export capital to the countries that aren't saving much, and that will even out GDP, which will actually be identical across the whole world, given a perfect global capital market. The local savings rates will make no difference whatsoever. Okay, so this model is completely failing to explain differences between GDP between countries. Okay, I think I've been going on for a while. Again, I'm going to stop this video here.